named Wire-Free and Worry-Free. If you don't know me, my name is Reimer Karls-Masur. I'm working for the DFN CERT in Germany, and I'm hosting this session. I'm also a member of this year's program committee. So we were looking at stuff to actually ease up end users' experience with wireless devices, let it be Wi-Fi or 3G, 4G things, devices. So, and I think the program committee chose 3 very interesting presentations from guys working in Denmark, in the Netherlands, and in Luxembourg. And yeah, so we've got Hao Yu from the Technical University of Denmark, and he's presenting us a research work he's doing on vertical handover, seamless handover from Wi-Fi to 3G, 4G networks. Then we'll have Frans Panken from SurfNet. He's talking about the creation of an eduroam-like authentication mechanism for mechanism for authenticating mobile devices users in LTE, 3G, 4G data connections. And then last but not least, Stefan Winter will bring some sense to us, I hope. And he's talking about some research he's doing with some colleagues in NG on Open Call about EAP, supplicants, security and usage, and will tell us about his EAP lab as well, I hope. So now let me introduce you to Hao Yu from the Technical University in Denmark, where he's holding a postdoc position, and his research interests are in multi-domain networking, SDNs, and next-generation internet, amongst many others, I think. So the floor is yours.
Thank you. Good afternoon. My name is Hao. I'm here to present software-defined networking in heterogeneous read-o-ram access network. So the agenda of my presentation is as follows. First of all, I'll give you an introduction of some concepts and also the background of the problem. Then I'll guide you into the problem we're facing, and then I'll propose an idea of how to solve this vertical handover in the heterogeneous radio access network, and then a summary and questions. Yeah. So first of all, let's talk about radio over fiber and heterogeneous RAN. And RF stands for radio over fiber, and it's a bunch of technology that allow radio signal to be modulated and transmitted over optical fibers. So in order to expand the reach of either a base station or a wireless router. And it also allows various signals to be transmitted on the optical fiber to the remote radio head, so that we can provide various access technologies to the users. And this is actually the foundation for this. And because we have this radio over fiber possibility, then one universal radio access will no longer be a valid scenario anymore, because the devices we have will have a lot of access methods available in the RAN. For example, 4G, 3G, or Wi-Fi. And therefore, we have a heterogeneous radio access network. I'm not talking about multiple operators. This is very possible in the future that one operator will operate 4G, 3G, and Wi-Fi at the same time through a very flexible and simple architecture or infrastructure due to this technology possibilities here. Yeah. So good. we're going to have this. But in here, we're going to have some problems. Because in this HRAN, we'll have to have handovers. And so your devices, like your iPhone or Android phone or tablet or even wearable devices, will be surrounded by a lot of signals, a lot of layer 2 technologies for access. So very possible you will see this. You will see your phone switching from 4G to a Wi-Fi sometimes. We're entering into a building or into a cafe or in somewhere else. And by doing this, your device actually switches from one access type, for example, LTE, to the other, Wi-Fi, and that is referred to as vertical handover. While keeping the access type unchanged, like this, we refer to as horizontal handover. And the problem of handover, mainly found in vertical handover, is the disturbance in user experience. And why is that? It's because this. Well, the disturbance problem can be found in both types, but mainly we'll have this issue in vertical handover. And because it's caused by the change of IP address acquired by your devices from the attached network. And what does it mean here is when you switch from one access type to the other, your IP address will be changed. And once your IP address is changed, I mean the IP address assigned to your mobile device is changed, then unfortunately all the TCP traffic has to be reestablished, and which means all the applications that use the TCP will have to be either refreshed or re-log in or reconnect, just redone everything. So it's not a good experience for users, and this is actually due to the problem rooted in the dual roles of IP address, because as you can see, we have the locator role for IP address and also the identifier role for the IP address. So the locator roles here means how to reach the node that is using a specific destination address by means of routing. So OSPF and RIP and ISSS is doing this work. Basically, it's telling the system where this node is. And the other one is used by the upper layer protocols like TCP to identify the endpoints, basically telling who this is. This is perfect in a static scenario, but it's going to cause some problem in a mobile world. So after years of research and development, IETF has standardized proxy mobile IPv6 to support some network-based localized mobility management other than host-based due to some security complexity issues. Well, the good thing is this protocol is for building a common and access technology independent mobile core, so it can provide handover for Wi-Fi via WLAN or 3GPP. So the basic idea here is you have a localized mobility domain or LMD here, and in this domain the devices are supported with the mobility freedom here, and you have several mobile access gateway MAGs. And they're responsible for taking care of the details of the handover from layer 2 to this is discovery of either this node belongs to this domain or what. And per domain we have a localized mobility anchor and a MA here, and it functions like the home agent. And it also is the gateway of all the traffic sending to and from the device to the outside world. Now this is a protocol standardized by IETF. But some more details about this is, so as long as you have a mobile X enter into the realm of MAC2, for example, here. And the MAC will say, okay, I'll send a proxy binding update message to my anchor saying that, okay, please send everything bound for X to me. And then an ACK message will be sent back to the MAC from the anchor. And then a bidirectional tunnel will be established between the anchor and the MAC. The traffic sent to the X here will be still received by the anchor because there's no change in the home IP address. If there's no change in the home IP address, the TCP won't have to be reestablished. So everything works fine. And then when the traffic reaches here, it will be reaches here, the traffic will be decapsulated and the content will be sent to the X from MAC2. Yeah, but the problem here is this protocol works only for one domain. There's nothing about multi-domains, and this is actually the problem we're facing here for multi-domains. So the idea here, well, first of all, let me give you the use case, because you might wonder why we should have this problem. This might not be a problem. The thing is, for example, if we have eduroam in LTE, at that time, you or a single person will have one universal profile, for example. And then you might, walking along the campus from this building to the other. Then it's very possible that your device, wearable device, your phone or a tablet, and will switch from Wi-Fi to LTE and then from LTE to back to Wi-Fi again, while you're using some applications like e-learning, mobile learning on your devices. And then you don't want to re-log in, you don't want to refresh your page and so on. So the use case is this. And the idea for seamless handover using this protocol with SDN assistance is proposed here. And the beauty of SDN here is to decouple the control plane and the data plane and put all the control plane into a software or called controller. So surrounded or centered by this controller, we can have southbound API, northbound API, west and eastbound API. And the southbound API is responsible for communicating the messages from controller and to this hardware and devices. And northbound APIs are responsible for providing functionalities to the upper layer applications, traffic engineering or mobility management or traffic monitoring. And the eastern westbound APIs are responsible for the communications between controllers. So this idea is beautiful. And then how can we use this idea to solve our handover problem? For example, we have two domains like this, and currently we don't have a solution for this, but what if we have a SDN controller per domain connecting to their anchor and the MAC, and then we can have a multi-domain tunnel set up by the controller because they're very good at it. They're good at moving traffic, moving network resources to create tunnels and to forward all the flows. So why not just use their capabilities here? So since we're maintaining the IP address unchanged, the traffic sent from the internet or from the server will still be received by the home anchor. Well, this node is here. It belongs to this domain here. And this anchor is this node's home anchor. So the traffic will still be received by the home anchor, and the home anchor will have to forward the traffic just as the PM IPv6 did. We have to forward this traffic through the tunnel back to the other domain, and then traffic can be decapsulated and sent to the node, as here. So in order to do this, we need to enhance the PM IPv6 a little bit. How to do this is still like this. So as long as our node X enters into a new domain, a domain B, and this will be discovered by the MAC-B. And the MAC-B will say, okay, I'm going to send a message to my anchor saying that please forward all the traffic bound for this X from domain A to me. And well, this works the same as PM IPv6, but now things are changed. We need the anchor B to also send an update message to its peer, the anchor A, saying that, okay, please send everything bound for your X to us, to this combo, to this anchor B plus MAC-B. And then the anchor B needs to tell its controller, set up a interdomain tunnel, and then it's the controller A and controller B's job to jointly establish an interdomain tunnel for the traffic. And as long as tunnel is finished, then we have a tunnel OK message from controller A. And then anchor A will say, okay, now your handover procedure is over, and then the MAC-B the anchor B will notify the MAC-B, and the MAC-B will further notify the X, saying it's over. So then what we need here is an enhanced PM IPv6 protocol, and we need to have agreements between domains, and we also need to have a west and east-bound APIs for the communication between controllers in order for them to establish that multi-domain tunnels on the data plane. Well, yeah, some details about this. First of all, we'll have a guest LMA. It needs to send this kind of a message to the home LMA. So the whole branch here will be considered as a giant or super MAC to this LMA here. And the home LMA will consider this branch as a super MAC. And we need to have a tunnel established between these two domains by the assistance from the SDN controllers. And the downlink traffic will still be received by this home LMA due to the unchanged IP address. Well, the side effect is the traffic will have to travel a longer path, just as you can see here. We cannot do this way because, well, we'll have to face an IP change if we send the traffic this way. And then if we change the IP address, then we have to, the goal is not reached. So by only doing this, we can preserve our home address unchanged, and we can provide a seamless handover between domains. So to summarize, well, this proxy mobile IPv6, it provides a network-based mobility management supporting IP network, which is very popular in operators. They're supporting this. But there lacks the ability to provide multi-domain mobility management. So we need to have an enhanced version of the proxy mobile IPv6. And this research is about how to provide a seamless handover in multi-domain HRAN. But this one is challenging, and it needs to be solved if we have an eduroam everywhere in LTE world and also in the Wi-Fi world. Then we have to face this kind of situation here. And the work here is to propose an enhanced protocol on the signaling path, and on the data path, we have to seek the help from SDN controllers. So basically, it's about two parts. On the signaling path, we will have an enhanced proxy mobile IPv6 protocol. And also on the data path, we'll have to see how we can establish this multi-domain tunnels with SDN controllers. So that's it. any questions.
Okay, thank you, Hao. Thank you very much, indeed. So, are there any questions from you guys? Stefan, yes.
So you need a lot of infrastructure to solve this problem. I'm sure you can solve it with this approach. Looks really like a very sane way forward. My question is a bit coming from the offside here.
Yeah.
I am a user of 3G and 4G and Wi-Fi, and I do this handover quite a lot of times. It is occasionally a couple hundred milliseconds, and most TCP sessions are short-lived anyway. So I wonder, where is the driving force coming to do this very complex stuff? Is it actually end users complaining all the time that they have this small gap of connectivity, or is it more like the 3GPP association saying, oh, we want to be perfect and have to close this gap? Do you know where this is coming from?
No, this is not coming from them. It's just a well, this handover problem it's been there for a while, and it's all due to this reestablishment of TCP traffic. It's not a force coming from any organizations, or it's just an idea of how to solve this. Yeah, as I said, the use case here. Here's the use case here. Yeah, this one here. It's very possible in the future that, for example, if you're walking out of the building to the campus or to the playground, and then you don't have Wi-Fi access, but you still have your eduroam profile there, and maybe you will expect, okay, if I have an eduroam profile unchanged, then why should I refresh or relog into any mobile learning applications anyway? So if we don't solve this problem, well, the users might be annoyed by this kind of, every time you have to, then you lost your freedom of walking around in the campus, or because it's eduroam, this thing is pretty brilliant, but yeah, if you're walking into cities, sometimes my mobile phone will pick up some eduroam signals and will join the eduroam, and then it will lost it as I walk. Yeah, so this is actually the background of this this idea. If we have a universal profile for eduroam, then I, as a user, will expect everything will be transparent. It should not, maybe, yeah.
Okay, thank you. Another question?
Rather not a question, but more than to remark regarding the previous one. First of all, do you use VPN by any chance on your mobile phone?
Yes, I do.
Does it reconnect if you switch between the domains?
No, it doesn't.
Okay. So first of all, it really has, the problem is how we use the mobile phone, the mobile devices, and what applications we do use. Now there are two ways to tackle this. Either this can be done in the network, that is, the network has to be intelligent enough to hand over seamlessly, or it could be done in the application or in the end device, so to speak. But in certain cases, you will have to bloat the device to extend the buffers and memory and processing power, and this may not be the case even if you are listening to some stream, but if you are in the interactive mode, like video conferencing, that is where where the applications are not the place to do this. That maybe the network is the place to do this. That's it.
Yeah, thank you.
Just up here.
Yeah.
Can you go back to slide 10, please?
Yeah. Which one? 10.
No, sorry.
And
Continue. The one with the
Here.
there. Yeah, one with the transit, the line. That there we go.
Yeah.
So, are we talking a continuous? This is going to highlight my lack of understanding. So, is it implied that the continuity of that circuit, or just transient in the moment of an authentication? Because I have a question around: is that my device across domains really just always resident on my home network? And the second part of that is, if so, where does settlement happen? Because if you're transiting, let's say, Vodafone over here and O2 on the right, someone's going to want to get paid. So can you either correct what I'm thinking, or so my question is there a continuous data? If I'm watching a video stream and I walk from here to there, am I still on the same network? And is there transit continuing being tunneled all the time?
Okay. Well, yeah, someone has to pay here.
Where would you put the laser pointer? Where's the payment? Where's the demarcation point at the PDN? Right in the middle there?
Well, I have to. This is. Yes. Well, this is for the traffic that needs to have an unchanged IP address here. It may not apply for videos or voice, because they can use UDP, and UDP doesn't care about the change of IP address. So we're here concerned about all the TCP traffic. And I think videos to boost their performance, videos are using UDP other than TCP. But let's say if we have a traffic coming this way, and I don't have a clear picture of who's going to pay for this and how this authentication is doing. Okay. Because also for eduroam, if we have eduroam in LTE, who's going to pay is also an open question here. About this, I'm not so clear about this. Yeah, I'm here only to focus how we can make this handover seamless possible.
So on that point, on the point of handover, is it implied then, in my mind, that device that at the bottom retains the address regardless of where it's handed over, so the destination traffic is always consistent, aka I'm always on my home network no matter where I am? Yeah,
because this device will have two addresses. One is home address, maintained by here, right, and the other one is care of address, maintained, it's just temporarily either assigned by this MAC or assigned by its home MAC. So that's why we have a tunnel here. The traffic sent by the remote server, for example, any server through the internet, will be using the home address. And by using this home anchor will receive that address, will receive that traffic, and then it will check its binding cache and forward all the traffic to the tunnel according to this where this.
Okay.
Yeah, according to this here. Yeah.
It gets very interesting to do a profile for eduroam when it's quite a complex thing. Thank you.
Yeah. And there's a question on the back.
Thanks. Yeah, just one last tiny question, please.
Thank you. Unfortunately, I did miss a little bit in the middle there, but when you was showing that before with the home agent and the care of address, I have some experience of traditional mobile IPv6. And I was just wondering why it didn't do the route optimization. So the first connection, when you contact the IPv6 address, the home IPv6 address will go via the home agent, but then all future ones should be via an optimization, because the client says, actually, this is my care of address, send all future packets to the care of address. So is it doing the optimization there? Or is it just always tunneling through the home agent?
Well, we have to use all the tunnel from the home agent, I'm afraid. Just like, where is it? Like it here.
Right, so there's no optimization.
Unfortunately, if we have to maintain this home address, then there's no optimization on that. We will have a longer delay of the traffic sent in this fashion here.
Okay.
But yeah, otherwise, then we'll have a changed IP address and everything is...
Well, no, with traditional mobile IPv6, a client can always contact you on your home address, but once it's made that initial connection, you can then say back to that client, actually, I'm on this address, and then it just switches over and uses your mobile address.
Yeah, but that's host-based solution, and that needs some security configuration profile on your devices, isn't it? And we're here talking about the network-based solution where you have a local local agent. So you don't have to signal from the device. You don't have to signal your home agent to change its routing state. So it all happens in the network, and your device just switch from one to the other.
Okay, thanks very much. Thank you very much, Hao. Can I get a round of applause for it, please? So, thanks again. Now we have Frans Panken from SurfNet, where he is working as a technical product manager in SurfNet's middleware service department, and today he is actually talking about the creation of an eduroam-like authentication mechanism for accessing LTE, 4G, 3G mobile services. So, Frans.
Thanks, Reimer. Good afternoon, guys. Thanks for joining this pre-graveyard session. I think the real graveyard session is tomorrow morning after the gala. I think this is a pre-graveyard, so I thought, how can I get your attention? And I think the way that I get your attention is by these wonderful information in addition to these great Dutch treats. So after the session, if you have good questions, you get actually rewarded by a stroopwafel, which is brought from the Netherlands. So let's see if you pay some attention, and I can give you some cookies. Already give some to Reiner, because I make this slide quite difficult. Not handing the slides on time. So here you are, Reimer. It's already okay. So this is about Meal. It's an open call project within the GEAN project, and I'm going to tell you a little bit about it in a second. But before going there, although this is results from this open call project, I work for SurfNet, and I work there in the team, in the mobile team, and this mobile team is called wire-free. Why is this wire-free, and why you have this complex equation? Is this because the team focus on wireless, and if we talk to wireless to institutions, they think wireless equals Wi-Fi. If we talk wireless, if we use the term wireless to a network operator, he says wireless equals cellular, this equals 3G, this equals 4G. So no, wireless is just a connection without wires. So because of these problems of wording, said let's choose another word and say wire-free, because then they immediately talk, what's wire-free? Wire-free is both cellular and Wi-Fi, so both worlds. So we have various activities there. We look at eduroam and 4G. We look at offering Wi-Fi as a service. We also have data procurement. And of course, we still look at eduroam, continuing the service as it is. and also making nice other services. Okay, regarding LTE, it's quite successful. Do you remember the tri-band phones that you had to have in the 90s to have actually calls in the US? So you needed to have tri-band phones. They supported 3 bands. This was in the mid-90s. And if you had a European phone, you went to the US, you couldn't use it because they used another band for GSM than they used in Europe. So this is why we had these tri-band phones. Well, guess what? LTE doesn't only have tri-bands, it has 25 different bands, 25 different frequency bands that can be used for data communication. And the most popular is the 1800 band, and then next to the most popular is the 2.6, and that is basically because bad statistics, because everybody has supported but nobody uses it. And then we have the series bands used in the US and in Europe, the 700 and the 800 bands. Today, in quarter number 1, already 288 operators in the world commercially have LTE launched in 104 countries. Eduroam is served in 85 countries. 250 million subscribers already worldwide, more than 1,500 devices. We have adoption of another 100 megahertz band for LTE usage and it's already deployed in Africa. It's already used in Asia. We have Cat4. Cat4 means 150 megabits downstream LTE. 150 megabits wireless, public. This is already in Telecom New Zealand. This is in Vodafone New Zealand. This is in Telia Sonera. Is this going to be the replacement of your DSL connection? Not yet. But apart from Cat4, there's already more dots on the horizon because we have LTE Advanced. And this is making use of multi-carriers, adding carriers to one another to have even more capacity. And then non-technical, there's quite some regulations about mobile communications in the last few years. I think prices already for calls, SMS, data, they dropped for 80% if you compare it to 2007. But also, recently a network agnostic way to deal with SIM cards was announced in the Netherlands. We have quite some pressure from the European Commission to share spectrum. They realized that, okay, yes, we have this band for mobile communication, we have a band for satellite communication, we have a band for broadcast. This cannot continue. So although the Netherlands already paid $3.4 billion for using spectrum for only 17 years, European Commission realized that this cannot continue. Spectrum cannot be reinvented. So you have to use it effectively. And there is, from December 2015 forward, no roaming fees within the UA. And I was among people that were jumping up and down, saying, we have no roaming fees anymore in Europe. Well, guess what? Guess what happens if you have this operator, your domestic operator, and he reserves this much for international calls and this much for domestic calls. Well, guess what happens if the EC reduces the international calls? People for domestic will just pay more. This is the law of economics. So wait before you jump up and down about that there's not going to be any roaming fees anymore. The message I want to give with this slide is this: LTE is a technology that stays. It's there for the stay. It is mature. There's no discussion about WiMAX. So, well, the NREN community, if they have to make a choice regarding a broader mobile access technology than only Wi-Fi, this is the one that you should choose. Why is it so important? Is it the speed? Nah. It's the difference between HSPA plus dual channel used today with 4G, 3G I mean, and LTE. Well, the majority of LTE speeds, they are neglectable. They're the same. But LTE uses spectrum more efficiently. It takes data communication as a starting point. In contrast to 3G, which is, if you look at the architecture for 3G, it's a voice network where you can do data. LTE is a data network where you can do voice. The link is far more fragile, so if you walk into the border of the cell site, you keep your connection with LTE, whereas with 3G, people close to the antenna have to shut down the power in order to favor those that are close to the boundaries. And very much like for mobile operators, there are built-in tools for self-optimization and self-regulation, which means that you have micro, pico, femto, macro cell, and you can easily manage that over a large network. And, well, voice over LTE, which is just an application over LTE. And the challenge there is to make sure that it falls back if you don't have LTE. So you have a data voice over packet, and they have to switch back to circuit switch voice, which was a challenge. It's commercially offered now today. So all about LTE, but what about the NREN? Why should the NREN look into LTE? Because is LTE going to replace Wi-Fi? No. I don't think so. Wi-Fi is for indoor, LTE is for outdoor. They're complementary to one another. But why should we look into it? But first of all, institutions, they give their staff mobile phones. They give them a mobile workplace, which includes a SIM card. And they need a procurement to do that. And in this procurement, if you choose KPN in year number 1 and you choose Vodafone year number 5, you actually have to change all the SIM cards from all the staff, which is quite expensive, which is troublesome. And these guys want to make indoor calls, but the signal is actually blocked by foil on windows, by concrete. Indoor calls are quite difficult, whereas, depending on who you're talking to, 50 to 70% of all GSM calls are made indoor. And at the same time, equipment vendors, they sell modules that you can switch on, that you can click in your Wi-Fi network, and you have an LTE network. So you can expand your university's Wi-Fi network with LTE. And these SIM cards, they provide you with a much stronger authentication than user and username and password can give you. So if you need services that have a more secure level of authentication, the SIM card is actually very useful to use for that purpose. And the SIM card is not just a SIM card as we know it. Actually, its SIM is an application on a smart card. Smart card can be used for much more purposes than only a SIM. It can also be used for federated services and stronger authentication. There is need for redundancy in access networks. You see it in academic hospitals. They don't rely on Wi-Fi only. They need a second mobile network because of their business, and they need guaranteed SMS. If you are in a hospital, they have a messaging service bus, and they message surgeon. There's no operator in the world that can make guarantees on delivering of SMS. Whereas these surgeons, they need SMS to be definitely guaranteed delivery. Life are at stakes there. There's this shared MNC. This is the agnostic SIM card, which started in the Netherlands, and it's booming, I can tell you. Lots of people are looking at it, and it will not limit to the Netherlands only. What does it mean? It means that an NREN can actually have its own mobile network code. It means that an NREN can make its own SIM cards, and institutions can use that SIM card, and if a procurement in 5-year times will take place, the SIM card doesn't need to be changed, because if you have O2 first, and then you switch to Vodafone, this can easily be handled over the air if you have your own SIM card. This is an important one, mobile learning. Yesterday's keynote was about learning takes place everywhere. Flipping the classroom, all kinds of situations that you learn not only within the campus, the boundaries of your campus, but also outside the boundaries. So how are you going to support mobile learning, having access everywhere without a proper access network? I'm actually surprised that CIOs of institutes are not banging on our door saying, wake up, we have our mobile infrastructure, our mobile learning infrastructure. We have the content, but in time we need a network that supports it. And, well, last but not least, if you have an integrated LTE environment, you can actually have an integrated Wi-Fi and LTE coupled together. And, not having the problems that Hao presented before about multiple domains to have handover, because then you have an integrated solution if these NRENs support LTE. So how can you do it? Well, I see two possibilities. At the left-hand side, you can say, okay, we offer a public APN. What's an APN? APN stands for Access Point Name. It is the gateway from the mobile network infrastructure to your internet. So NRENs can offer this, and we already do this in the Netherlands, so we bridge the research institutions with these mobile operators. It is not limited to one operator, it can be applied to many of them, and it allows institutions to offer a transparent ICT solution, because for them, we hide the complexity of the LTE network completely. We hide the GTP tunnels, we hide all the diameter complexity. The only thing they see is Ethernet and radius. And guess what? They can handle that pretty well. At the right-hand side is, well, you can become a mobile virtual network operator as an NREN. You can offer your own mobile services. And that means that you have your own SIM card, you can do your branding, and you have control over the SIM card. You can offer an integrated service with your Wi-Fi. So this is how you would then realize it technically. And you have two flavors there. You can either say, okay, I connect. At the left-hand side, we have the LTE operator. At the right-hand side, we have the NREN. And you connect to them and say, okay, then we receive the packets and we route, as the NREN, we route it to the internet. Or alternatively, watch closely, you can switch it to the institute such that the institute can handle all the traffic and basically see this as a one big giant Wi-Fi access point, because what they see is Ethernet traffic and radius authentications to authenticate to the APN. And the alternative for the MVNO is that you move these boxes over here, the complexity, these functional entities, you move them from the LTE network to your own domain and do the business over there and have a real, from a consumer point of view, a virtual network operator. How much are we on time? Let's skip this one. Okay, then come back to Meal. This is a project that we do in context of GN3+, and there are only two NRENs involved, and that's SurfNet and Janet. And we do both. We have APN and MVNO. So at Janet, they focus mainly on the APN solution, and in the Netherlands, we have both the APN and have experience with an MVNO construction, which means that if you are in the UK and you travel to the Netherlands, and you switch on your phone, then traffic is not longer going to an operator, it is going to this APN that SurfNet supplies, and then we handle the traffic on behalf of the people from Janet in the UK. And of course, the same happens when people travel from the Netherlands to the UK. Traffic will then be routed to the APN for SurfNet, and it's just configured on your phone which APN to use. A little bit about a SIM card, because this is important. I think this is the most important piece of the puzzle. And before I explain this piece of the puzzle, I would like to explain a very basic what is on the SIM card, and the SIM card contains an IMSI. Complex name for something very simple. It consists of a mobile country code, a mobile network code, and an identifier that identifies the number of the subscriber. So for instance, we have 801 is the mobile country code for the Netherlands. So all operators in the Netherlands, they have mobile country code 208. And then within 208, there are 99 mobile network country codes. And KPN uses 08 and Vodafone uses 04. And then if you are abroad, then the mobile operator that serves that country, it recognizes the mobile country code, it recognizes the mobile network code, and with that combination, uniquely identifies your home mobile network operator. What I would like to have is an international mobile network code that can be used for research and education. And there is one, and that is the 901 code. So it's within a country code 901, this is an international country code. It's not bounded to one specific country. It can be used in any country. So if an NREN, if we as NREN community have a mobile network code within this international country code, we can make our own services, and we can make our own SIM cards. And if you use these SIM cards, each NREN can choose its own mobile network operator to treat the traffic. And for that mobile network operator, it remains the same if you do it in the Netherlands, or you do it in the UK, or you do it in France, or you do it in Luxembourg, or whatever. It sees the combination of 901, International Mobile Network Code, with the mobile network code assigned to the research and education community, and it routes it to its local NREN. So it doesn't need to be bothered with, oh, this is one for Janet, this is one for another NREN. It can be kept local. And then we as an NREN community can then forward the authentications to the one that it's already associated with. So how do we do this? Based on this MSIN. We can just have a simple database lookup and say, okay, where does this user belong to? Of course, we need a governance to assign numbers and distribute number plans, but we have Dente. They can do that. It's like IP routing. We know how to do that. So if only we had this international mobile network code for the RNE community. Let me repeat what I said before. SurfNet can ask KPN in the Netherlands to offer us with these mobile subscription. And the same thing EE can do in the UK for Janet. When a Dutch person goes to the UK, it switches on his phone, and the EE just sees, oh, this is a user from Janet. Which is not the case, but they don't know. They cannot identify this. So they say this is local traffic. And it doesn't only apply to the UK, it applies to every country in the world where there is an NREN. Well, there are sufficient of those. So you can choose your own mobile network operator to handle traffic. And then when traffic, the mobile operator just sees the local NREN, identifies it with the local NREN, and we can just use the federated authentication approach, same thing as we do with eduroam, to forward authentication request to the NREN where the user belongs to, and make the proper authentication end-to-end as we do with eduroam. And as 4G operators and 3G operators also do. Then route the traffic to the internet as we do with the fixed infrastructures. No SIM card changes when a NREN chooses for another operator. We can configure this over the air. Of course, if you have your own SIM card, you have control over the SIM card. You can extend it with other applications for federated services. And there must be, of course, some payment between operators when they roam. I think we can figure it out. And especially with the no roaming fees in the UA, payment is not important anymore. So how do we get an international mobile code? No, mobile network code. Well, it is granted by the ITU. And that's the only place who can give it to us. And who are the members of the ITU? That's our government. Our government is a member of the ITU and has votes to vote, yes, vote for an international mobile network code for the RNA community. But be careful, MNCs are rare. There are only 86 left worldwide. So the ITU is not going to give it to us when we don't ask for it, and we will have to knock on their door quite hard before they are convinced to give it to us. But let's start this exercise. And there's already a precedent because the United Nations received an international mobile network code. And I went to the Dutch government and I said, are you willing to support us? Are you willing, as the Ministry of Economic Affairs in the Netherlands, are you willing to vote yes for an international mobile network code for the RNA community worldwide? And they say, yes, we will do this. But you must first do your own homework. You must first make sure that every NREN in each country will do the same lobbying process, because we are not going to stay there as the only country in the world saying, yes, we will do this, and then there's not going to be enough sufficient political support for that. So this is a request from me to say, okay, let's start a lobbying process and see how we can move forward to each of the governments that support an NREN and say, yes, let's vote for a mobile network code, an international mobile network code for the research and education people. So, yeah, please come to me or advise me what to do, because I've talked to this about to many people, but the problem is that the strategic people say, oh, this is technical. And the technical people say, oh, this is a great idea, but this is only strategic. So I'm stuck here. So please help. Thank you. Remember the treats. If there are questions, is there room for treats?
Thank you very much. There are actually a few minutes left, I think. So, are there any questions for Frans? There's one. Yes.
So, how many free MNCs are there?
86.
And how many NRENs are there?
Well, you need only one for the whole world.
One for the whole world?
Yeah.
Okay. And then how many phone numbers do you have under that?
You can serve 10 billion users under one MNC.
Okay. And how many do we need?
Well, let's start with one. They're good. Thanks for the question.
Thank you. I think we can take
Oh,
one more
Ramoondas.
question.
One more question. Oh,
Which one?
there can be treats afterwards.
Rather remark.
You have to earn the treat, Ramoondas.
Yeah.
It doesn't come for free.
Okay. So first of all, Does anybody know any contact within the United Nations? I do believe it was healthcare something division who actually got this international MNC? Anybody? No? Okay. And then the next thing would be, I think that, okay, we are all Europeans and all sorts of things, but it would substantially improve our claim for international mobile network code if the US guys would be supporting this as well. Research and education community and government of the United States. That's, I don't know if I did earn the. And the third thing, governance. I don't. Well, with all due respect for Dante, Dante is sort of European entity, and we also got talks with NREN enum guys who have this NREN enum resource globally, and they already got the global governance model, so to speak, for the international resource. Oh, that's it.
Yeah, there's some discussion with Peter. Just enjoy your sweet, Raimundo.
So, thank you very much. So, thanks again, Frans, for your nice presentation. Very interesting. Just a quick round of applause, I think. Thank you. And now I want to turn over to Stefan Winter. Stefan works for the Luxembourg's NREN Ristina. He's an R&D engineer there, and he's, well, working in the eduroam realm, I'd say, in operations and further development, and has lots of things to do, doing an federation, looking at security of, well, supplicants and so on. So he's very busy, and he's giving us some sense now, I hope. So we can go all to the gala dinner with more brains. Thank you.
Okay, thank you for this introduction. So let's talk about this SENS project. As you can see here, it is a mildly funny acronym which expands to Secure Enterprise Networks, Simple and Easy. What you can also see is that it does not talk about eduroam. Now the thing is, what we do here hopefully is beneficial for eduroam, all right? But the message is framed a bit differently. Excuse me. Because if you tell a vendor, you have to fix this and that in your software to make eduroam better, probably the answer is, well, why would I do that? It costs me money, and what is this eduroam anyway? But if you frame the message a bit differently and say, look, you are a vendor of an enterprise network client, and all of your enterprise network customers will have the same problem that we have in eduroam. So it is in your own interest to fix your product so that everybody can use it better. That is a whole different story. So that is why we say this is all about enterprise networking. So this is WPA2 with radio servers, all the stuff we do in eduroam, but it is not sold as being an eduroam thing. Please keep that in mind. So let's first talk about where did this SENS thing come from. So we are part of the GEANT Open Core Initiative, just like the MEAL project, which was presenting before me. And there are 21 of those, and basically it's venture capital handed out by GEANT. So the second bullet is how the money flows. So this is actually FP7 money from the European Commission giving to the Gen 3 Plus project, but they're obliged to give it out to those micro projects which they find worthy of funding, and SENS is one of those. SENS is a consortium comprised of 2 NRENs, so there is PSNC in Poland and Ristina in Luxembourg. So what do we do in SENS? Our goal is to make enterprise networking easier and more secure at the same time. Usually if you make something easier, you just neglect some security settings, but we don't want to do that. We think the industry can do a bit better. So we have trying to tackle this problem from several perspectives. So for the user, it's supposed to get easier. So if you configure eduroam or any other enterprise network, there should not be a need to understand all the technobabble we have, like CAE certificate validation and put the server name here and all that stuff. It would be good if this would just work automatically. And particularly, you shouldn't have to follow a PDF with 20 pages of screenshots and instructions what to do. This is just not practical. Ideally, for the user, it just works. Those of you who have an Apple device on iOS or macOS probably say, oh, this is all a done deal because that's what my iOS does. I just click on this profile for eduroam and it just says install, okay, fine. That's true, but that is just Apple iOS. It is a shining example of where we want to get to with many more supplicants, not just that one. Furthermore, if you are an eduroam or enterprise network admin, you probably have seen eduroam-cat, and you see that it has multiple flavors of all these profiles. So there is something for Windows, there is something for macOS, there is something for Linux. All of them speak different languages to the actual device. So for us, providing eduroam-cat, it is quite a bit of work to produce all these files. But for the admin, it's also quite a bit of work to put them all on their websites, have different support instructions, and so on. So ideally, this wouldn't have to be like that. There could be a standard which just describes how is your EAP deployment, your EAP deployment, going on your institution. So what is EAP for you? Put that in a config file, which is understood by every device out there. And no matter what device you have, you just click on it, and it does work. Also, we want to give admins another help by the side. So if they are bootstrapping an enterprise Wi-Fi network, and they don't have a radio server yet, or they just become a service provider only, so they don't ever have a radio server, we want to give them an opportunity to just try out, are we actually doing well? So can we use this setup here? Did we do something wrong? So somehow, can we verify that we would be a good participant in a production environment without actually connecting them to the production environment? Lastly, the usage of, or the usability of eduroam and enterprise networks stands and falls with the usability of these client devices, because that is what gets interactive with the user. So we want to give people a way to test, if I'm writing a supplicant, how does my supplicant behave if something strange comes along, which is not just the normal authentication. Something goes wrong, I get a strange packet. How do I react? What do I tell the user? And then I may be telling him something strange. So I like to subsume this as understanding the good, the bad, and the ugly about supplicant design, user interface design, and functionality design. Now that is quite something. So we have quite something on our plate here. So how do we solve these problems, or how do we approach these problems? Well, we have four work items in Sense. And the first one of those is the standardization of the config file format so that every device in a distant future is able to understand that and just use it and not have hundreds of flavors. We call it the EAP metadata file format, and this would be the common language for EAP config. I go into details with all these work items on the following slides. The second work item would be supplicant assessment. This is taking a look at what's out there. How do supplicants behave? Why do they behave strangely? And what could you do better there? The third work item being the EAP lab. So we have a test lab where you can just plug in with your Wi-Fi access points, with your EAP supplicants, try to authenticate, and tell us, please do something wrong, and so that we can actually do something wrong and the user sees how does my device behave. And the fourth pillar we have is then actually taking code in our hands. So for some supplicants, we have access to the code. These are the open source projects. Nobody from the big guys actually gave us access to anything. So on some of these open source platforms, we can actually try to improve the supplicants which are out there just by getting their hands dirty on the actual code. So for the work item 1, the EAP metadata standardization, this is nothing less than going to the guys who defined EAP in the first place. This is the IETF. So this started from having a feeling that, so the IETF created EAP. It's a very complex protocol. You have to push various knobs to get the deployment right. But they did not provide any means of specifying what a specific deployment profile is. So what we do is actually go to the IETF, propose a file format where you can have all these finesses which can be in an EAP deployment, and there are really many. And you can specify these in a file in some format. We are thinking XML, but, well, the IETF thinks differently. And then when this standard is out there and the IETF has said, yes, this is a good thing, hopefully the industry would adopt this file format in their devices so that it can be consumed by client devices. Despite just having the raw EAP details in the file, we also have space to identify to the user, so who is this guy offering me a profile? There can be a logo of the identity provider, the name can be in there, and acceptable use policies, and various more stuff, basically what you get with the Apple iOS profiles, and more. We also have a non-goal in this work item 1. While we do care about EAP properties, we realized that Wi-Fi itself also has various knobs to push. But that is something we can't take to the IETF because it is an IEEE space, and we don't have so many ties there. So the Wi-Fi properties have been separated out. We care about EAP configuration on its own, and that is what we aim to standardize in the IETF. That being said, we also have a Wi-Fi configuration format as a companion, just because we deploy Wi-Fi to client devices, so we need to have something. But we are not aiming at standardization with that. This is just for internal use. So how far did we get with this? Well, actually, we went to the IETF. So there is a what they call Internet Draft, or ID. So we have an XML file format, which basically expresses all the things we think we need to have. Taken from existing ones, there is a Microsoft XML format. There is the Apple XML format. Some things which were forgotten by both, so we added our own stuff to it. And this is what came out of it. If you care about it, give it a read. We actually presented this at the IETF meeting 89, which was in London just a couple of months ago. And actually, there was an audience, the operations and management area working group. And I can say there was a mild amount of interest. So this is not the new thing that shatters the world. It's just solving a small, very specific problem. But we were basically getting positive results. Maybe not an acclamation, but people were sympathetic. We did get one significant question, and that's why we still have to work on this one. It's not finalized. So we thought XML is a good idea, but the IETF actually has a different protocol for configuration information, and it is called YANG. Does anybody of you know YANG? Please raise your hand. Nobody knows YANG. OK. Maybe you know SNMP. So SNMP is a bit more popular. But the IETF has decided SNMP is too complex and is gradually phasing out the use of SNMP in new protocols. So you have a new language, not the old MIB modules, but now you have YANG modules. And they are the containers for information for the configuration of network devices. So this will be coming at an, I don't know, Cisco iOS version in 5 years or so, because it's really very young. But still, we got the question. So this is configuration information for network devices. Why don't you do this in YANG? Well, we don't know. I didn't know much about YANG before. The good thing is, if we do this in YANG, there are automatic conversion tools which generate XML schema from it, and which also generate JSON files from it. So when we do it in YANG, we might still have XML. So it may not be a big thing, but this still remains to be seen. This is work in progress. The second work item, supplicant assessment, basically this is defining criteria. So what should a supplicant do, what should it not do, and what is really a no-go. And we're taking a look at how do these supplicants behave. So do they get all the EAP security parameters right? Do they forget asking the user about what is the CA certificate, and these exist? Do they have side effects on system security beyond EAP? This also exists. Are there interoperability problems? So a device which only supports USIM and not any of the username password-based devices can't call itself a complete EAP supplicant because it just caters for a very small use case, or maybe it's a big use case, but not enough use cases. So that is something to test against as well. Then we have also the user interface. How does the device present itself to the user? Are there some big no-goes which you really shouldn't do? And finally, can you provision in some way or another automatically the configuration details to the device? So this will become a checklist. Those of you who know the German TÜV might at some point have heard of this one. So basically, we created a checkmark list. What do we like to see? Is it there? Yes or no? And then we assign a score to the supplicant and say, this is really good supplicant and this is really bad supplicant. How far did we get? Well, it is still work in progress. I have this as a file on my PC, and I didn't release it yet. What we have seen is that the classic security options are well known. Some supplicants lapse in that area, so they don't ask for the server name. If you know enough about EAP, that is important. But we also found some interesting things that implementers of supplicants don't often think about, it seems. So we found a Trojan horse approach. So when you specify EAP details, you have to say the server certificate comes from this and that CA. Now, if that CA is not in the browser store already, we have to import it to the device so that it's known as a root CA. Now, what many devices seem to do is that they see, oh, a new root CA, so let me import it in my store. And all of a sudden, that CA becomes trusted, full stop. So it also becomes trusted if I would present a web server with a certificate from that same CA. All of a sudden, that web server would become trusted. But actually, I just want EAP. I want this to trust my Wi-Fi deployment and nothing else. So devices which don't make any distinction here will just have the assumption that, oh, the user imported a CA, he trusts it. So yeah, an IMAP server or web server probably is also fine if it comes from that CA. If you just have a relationship with a Wi-Fi provider, that is just not true. Another thing is also, does the supplicant have meaningful error messages for the user? Well, okay, I see shaking of heads. So this is where most actually fail. So what we see is that many supplicants, whatever goes wrong in the authentication, even if the radio server is down and they never actually verify a password, they don't even send it to the server. But still, the message to the user usually is, well, didn't work, probably your password was wrong. This is not just unspecific advice, it's really wrong advice, and it creates help desk activity because people start calling, you know, what's wrong with my password, and it is just totally wrong. But this is out there, and many supplicants fall for that. So I think we will have a very interesting checklist and very interesting results when actually assessing supplicants against these criteria. Work item 3, the EAP lab. This is now where we start getting our heads dirty on actual code and software. So the idea is that we have that you bring an EAP supplicant, and you may want to test it against a well-behaved EAP server. So we have a radio server, we have usernames and passwords you can just use. They don't have any particular meaning. Of course, just in a lab environment, this is not eduroam, this is something separate. And you can see, right, can I authenticate? Does it all work? Did I code this right in my EAP supplicant? The more interesting part is that you can also tell the EAP lab, do something wrong. And then I can test my supplicant, can it cope with that? What is its error message? So some things you can configure is that the radio server supports only EAP methods which are totally exotic, and probably your supplicant doesn't support any of those. So what is my message to the user if I find out, oh, the EAP methods which I have on my device and those from the radio server just have no common match? That is not quite a common use case, but it may happen. So maybe your device does not support ePTLS, but your server only supports ePTLS. And then it would be good to have a meaningful error message, which means, well, either you have to reconfigure your device for this other EAP type, or if that doesn't work, talk to your system admin, but it is not a password problem. You really have a configuration issue here. Same thing, you can present a wrong CA during the exchange to the supplicant. We would hope that it complains and tells the user, wow, something's fishy here. Somebody might be setting up a rogue radio server. Then you can have the correct CA, but a wrong server name and numerous variations. So if you have access points, if you have a local service provider setup, you can just go to our website and read the IP address and shared secret for that radio server and plug your Wi-Fi access points to the EAP lab, and you're part of it. So there is no authentication required. We just have this greenfield deployment. Everybody can come and play with its EAP supplicants and with its Wi-Fi access points. Of course, we also use the EAP lab to test those criteria which we've set out in the previous work items. So when the checklist is finished, we use the EAP lab to trigger all these failure conditions and see how the supplicants behave and whether or not we can set the checkboxes. State of this, well, it's ready. So you can go there and start playing. So there is the URL, eaplab.supplicants.net. We have a set of really very promiscuous radio servers there. They tell you the one shared secret which is good for the world immediately. And if you don't want to bother at all, we also have a username and password to authenticate to on that same web page. So you just don't have to interact with the site at all, except for reading what's up there, and start connecting to the EAP-Lab. If, however, you do choose to log in, then you get more of the fanciness. The fixed configs we have on the public website all have the same scenario with the good CA, a good server name, a wide set of supported EAP types. So that's the boring case. And when you log in, you actually get your own control panel, and you can say what is supposed to happen. Next time I log in, give me a different CA, and so on. So we have like 15, I believe, different naughtinesses basically on the logged in part of this. So you can test various error conditions. And yeah, it's all up and working. Of course, we are going to do some more fine-tuning, add more test cases, and this is still ongoing, but it is usable right now. And as we will tell you in the demo, if you choose to come, we already have outside people, not NREN space, making use of this. The author of WPA Supplicant uses this EAP-Lab already to test various things on his EPOL tests and WPA Supplicant. So this is quite a success already, and we still have a couple of months to go in the project. Finally, work item 4. This is basically, yeah, using the source. So use the source loop is one of those open source jokes you sometimes get. If you don't get it, never mind. Here we actually try to influence supplicants. So assessing that they are maybe a suboptimal is one thing, but changing them so that they become better is something else. We have a person working on this for KDE. Actually, we have the core committer of the Plasma network management part of KDE. So this is what you use to configure your Wi-Fi. He has direct commit rights to the KDE tree. So whatever we tell him to do, he does it, and it ends up in the actual KDE, which is really quite good. So one thing we are working on is right now the error reporting. This is actually quite complex, but well, that's for offline discussion probably. Then we also touched the eduroam-cat. So we produce these XML files that I've talked about in work item 1 so that the world can consume them. This is all done and working. We actually produce them for one reason, because we also work on an Android app, which will require Android 4.3 or above. And it can consume this EAP metadata format and actually set up your Android phone for eduroam just fine. So most people say, oh, the Android app. So in this case, I can only say, come to the demo, and I will announce it in the last slide anyway. It is working in an alpha state, so it gets you connected to the network, it checks all the things. It is just not polished yet. So how far did we get? Yeah, the cat module is ready in its subversion trunk version, so the release 1.1 of eduroam-cat in the production version will also have it. But if you go to cat.eduroam.org, you will not see it there yet. For KDE, the big chunk we are chewing on is the error reporting. This is a bit of a sad story about the stacking of layers and open source projects. So we thought this is a UI issue because the supplicant has to tell the user the radio server didn't respond. So that's why we basically hired the KDE guy to do that. And then he said, right, but KDE Plasma NM only can display what it knows, and it fetches all its information from the NetworkManager daemon under Linux. And if that one doesn't export the current session state, and we don't know how far EAP has gotten, and if there was a radius reply, then we can't display anything to the user. So go talk to the to the NetworkManager daemon guys. And well, I talked to them. I opened the bug report in their bug tracker, and they said, oh yeah, but actually our daemon can only export what it can actually see from the supplicant. So the command line supplicant beyond us or below us is WPA supplicant. And it has a dbus interface, but it doesn't tell the world at large where it currently is with its EAP states. It just says, okay, I started, or didn't work. So basically, to get the message across to the user interface in KDE, you have to patch the command line supplicant, WPA supplicant. You have to patch the NetworkManager daemon, and then you can go to the user interface. This is quite a chunk of work to do. We are underway, but since we hired the guy from the top of the stack, this is quite a bit of work. Well, then we have a upcoming new Linux implementation for the eduroam-cat, which also consumes the config file format which is different from now. Right now, you download the bash script, which has the config info inline in the bash. So the future Linux cat module will be a generic, you wouldn't call it app on Linux, but an app which actually consumes the config file and does the right things. And finally, there is the Android implementation. It is underway, and it is in an alpha state, so you can use it. All that being said, I'm almost done. I would just to have one shameless plug here. So we have the EPLAB here. Well, you access it via a browser, so it's not difficult to bring it here. And we would like to tell you and show you what it can do and actually do it here on site. We also have the Android configuration app in its alpha state, and we'll bring that up on a big screen just to show you this is how Android works. And we can prove you, yes, it actually works. So if you want to see how does your phone react if an EAP server behaves funny, you can come along and just try it out live. Or if you want to see the Android app in action, we are in the demo room B at 11 o'clock tomorrow. So just come by, take a look. And I hope we will manage to impress you. Now, I'm standing here. I'm usually the guy who does the talking, but I'm not the guy who does all the coding and stuff. So this is actually quite a big consortium here. Here you see the consortium partners. There is many people from PSNC. There is also Nicolaus Copernicus University in Poland, which are the bulk of the manpower in the project. From Restena, it is actually just me. But all the third-party contractors we have, so the Android app development and the KDE Plasma and M development, that is something we outsource to third parties, and they run under the Restena umbrella. So that compensates for my small commitment in the project, and it's more or less balanced. So all these guys here are doing hard work to get the Sense project running, and basically to tell the industry out there, guys, EAP is not as perfect as you think it is, or as we would like it to be, so do something. Finally, as I usually say, a few words from our sponsors. So first of all, thank you, but then do take a look at the Geant.net Open Call initiative. I have to say, I am very happy that this kind of stuff exists. I know that people have very mixed feelings about Geant at times, but this is not your classical Geant. So this is really venture capital given out to something that is not the normal work program. And if the Open Call initiative decides to fund a project and give money to it, basically this project can just do what it said we would like to do. So there is no interfering with the goals, no bulky process. You get the money, and so long as you actually deliver the results that you are promised to deliver, you can just do your own thing. So very lightweight in the execution. I find this a very good thing. And this will also be repeated in Geant 4. So there will actually be an opportunity for you, if you feel like it, to run your own Open Call project.
You will have more sense in Geant 4.
Thank you.
So, thank you very much, Stefan. Very nice, interesting talk. Are there any questions for Stefan? No, no questions. This time I haven't a question for you. You have one?
The one he doesn't like, but I can shout actually. I've seen you mentioning alpha versions. Any plan or timetable when alpha will become beta, God forbid, version 1 and so on?
Yeah, I usually don't like these questions, and my answer is usually it's done when it's done, which is the default open source project attitude. This time it's different because we ran this same demo on Tuesday, and people were really ready to kill me to get a copy of the app. The pressure from Android users to get an Android app which does all the right things is really high. So I managed to commit myself to say there is a better version in 2 months' time, plus minus, and for the return of the students in October, hopefully we have something in the Play Store.
That's fine. Just let me explain. There are actually a lot. There is enough of Android applications that claim that they solve your eduroam problem while they do it in the worst possible manner, allowing man-in-the-middle attack, doing it really bad. So this kind of a tool comes just in time or a second after just in time. That's the reason why I'm asking.
Yeah.
Okay, thank you. I think we're done. So thanks a lot, Stefan. Thanks again.